Now we're going to learn about solving equations. So this is different than what we were doing with algebra because now an equation is something that has an equal sign in it. So we can solve this. It's like a puzzle to say, what would this variable have to be worth to make this statement true? And you can probably look at that and say the answer. You don't have to think real hard. What do I add to 3 to make it equal 7? So you're probably figured out that that has to be 4. So my answer here, the value of x that makes my statement true, is x equals 4. I'm going to take you through some examples and talk about a concept or a way that we can solve even harder equations. So first of all, 10 equals 10. Is this a true statement? Well, yes, it is. We know that's true. We can imagine an equal sign as acting like a scale balance or a teeter-totter. When each side has the same value, regardless of the appearance, it's considered equal or balanced. So we're thinking of the equal sign as the middle of the teeter-totter, and we're trying to keep the teeter-totter balanced at all times. Now let's look at these 4 questions, and I want you to decide if they're balanced. Is this true or false? Does 20 equal 18 plus 2? Yes, it does. Is 4 minus 19 equal to negative 15? Well, if you put that in your calculator, you'll see that yes, it is true. 45 divided by 15, if you put that in your calculator, you get 3. 12 minus 9 is also 3. So that one's balanced too. 9 times 8 is 72. 36 times 2 is 72. So these are all true because they are all balanced. They are equal to the same thing on both sides. So it's possible for the left and right side to be equal, but appear different. Now, what I want you to do is you can pause the video and try and figure out what each one of these blanks are, and then come back and check your answers. Okay, you're back. What do we multiply 12 by to get 24? You should have 2. What we're using right now is called the guess and check method. What do we subtract from 34 to get 11? Well, I have to, if I'm going to make this 4 into a 1, I'm going to have to subtract a 3. And if I'm going to make this 3 into a 1, I'm going to subtract 2. Now I'm going to check that in my calculator and make sure that that's right. 34 minus 23, yep, that's 11. Okay, this one. Something divided by 12 is equal to 5. So I guessed a bunch of numbers, and I found out that if I take 60 and I divide it by 12, I get 5. And this last one, this means multiply when I put things in brackets and they're stuck together. 2 things that are multiplied together to give me 42. Well, I know that 6 times 7 is 42, but it has to be a positive, and this is a negative. So I have to make this a negative times a negative. So this is not the method that I'm just showing you how to make true statements. This is not the method that we're going to use. I'm going to teach you a method that will always work for getting the answer, where you don't have to guess and you don't have to play with your calculator. So let's think about this one. Again, we're just guessing. Something times 2 plus 9. let's see, if I do 10, 2 times 10 is 20, plus 9 is 29. That's not big enough. So let's try 11. If I do 2 times 11, do I get 31? That's 22 plus 9. Yep, that works. Ooh, this one. 5 times something plus 6 will give me negative 14. I think it's going to have to be a negative number because that 14 is negative. So if I try 3, negative 3, I'd have negative 15 plus 6. That's not big enough. So I'm going to try negative 4. If I do negative 4 times 5, I get negative 20 plus 6. Negative 20 plus 6, negative 14. To determine the value of a variable, we can use 4 main mathematics operations: adding, subtracting, multiplying, and dividing. Our goal is to isolate the variable by itself. So that means that the coefficient in front of the variable is a 1. So we want it to say x equals some number. All right, we're going to do some examples. Instead of using blank spaces, we're going to use variables. That's what we use variables for in math, is just to represent what we don't know. And so instead of this blank here, we're going to use a letter A to represent that blank. Now, if I perform the same operation to both sides of this, does my statement remain true? So if I add, let's say, 1 to both sides, add 1 to this side, add 1 to this side, is it still true? It sure is. Both sides are equal to 11. What if instead, I'm going to divide both sides by 2. Both sides equal 5, so it's still true. I have to perform the same operation to both sides to keep my equation balanced. So the teeter-totter is balanced. We can use algebra tiles to help us to see the solution. So I'm going to start by showing you how to do this with algebra tiles. What I have modeled here with my tiles is n, so n is the blank, the box here, plus 3. So I have 3 positive tiles. And on this side, I have 7 positive tiles. So what we're going to do is use the zero principle to cancel things out. If I take and put a negative 1 with this, that made 0. So this is good. I want this side here, this side over here, to be just the box, and this side on the right to be just the counters. So I just added a negative 1 here to make this equal 0. So to keep things balanced, I have to add a negative 1 to this side. All right, I want to make this next part 0. So I have to add another negative 1. That means I have to add a negative on the other side. I still want to get rid of this, so I'm going to add another negative, but I have to put that on the other side too because I have to stay balanced. Now, these guys here that I've circled, they all equal 0, so I can get rid of them. That equals 0, so I'm just going to delete the whole bunch of them. I also here have these all made 0. So I can delete those guys. And I'm left with the box equals equals 4. So that means that my answer to this question is n equals 4. Now we can put that back up in the original question and check that it's right. I put a 4 here. 4 plus 3 equals 7. Now that may have seemed like a really simple example, but what I wanted to do was to show you the concept. This is the end of part 1. I have to separate the videos because they get too big for me to upload. Now I'm going to have you watch part 2.